I have a proposal for an architecture that will make building AI apps that are powered by Postgres much more scalable. And I have a demo for you today. So this demo, what it does is you can upload a document and it first gets uploaded. Then there's a processing step and you'll be able to chat with it. So once the step is done, you will have on the left here the document itself. And on the right, you'll be able to ask questions. So I can say, what is this document about? And what will happen is I will get an answer explaining what this document is about. So it says the document is the annual report for Apple. Now, you probably have seen this before. This is the hello world for RAG. And you're probably wondering, okay, what makes this special? And what makes it special is rather than having everything in a single database, so you have an embeddings table using pgvector, and you just store all the embeddings for all the documents in a single table, we actually give each user their own vector database. And this way, whenever you're doing RAG, like here in this case, I'm not actually querying my main application's database. I have an external vector database, which is, again, is just Postgres with pgvector on it, and I'm querying it, and I'm storing the user's embeddings in their own database. Now, you might be wondering, why would we do that? Well, the reason is, imagine in this app, each user has 100 documents, and each document has 100 pages. Well, what will happen is you will quickly have the embeddings table grow exponentially. And this will introduce challenges when it comes to scalability. You will have maybe, let's say you have one user that has 1,000 documents, and those 1,000 documents, each one is like 100 pages. So what will happen is you might have one user that has a big workload that affects the experience for all of your other users. So that's why we're proposing this architecture. And what it looks like in practice is essentially I have here, this is my project that I'm using for my application. So I have a user table. This here, just I have a single user. And here I have a documents table. And these documents, each document must belong to a user. And I have a vector databases table. And this table is essentially maintains a reference to an external vector database, which is Postgres with pgvector on it. And it also tracks which user this vector database belongs to. So yeah, and the way it actually works is I just have another Neon account, and this Neon account just is responsible for provisioning the projects. And here, for example, this project, if I go to the tables page, you will see that we only have a single table, which is embeddings. And this table, for each embedding, you just have the content, so the chunk itself from the PDF, as well as the corresponding vector embedding. So now, whenever a user asks a question, we don't have to go through a single table that has millions and millions of embeddings. We could actually work with a single database that has much, much fewer embeddings. And that's the idea. Now, you might be wondering, okay, all of this sounds cool in theory, but this probably is hard to implement, hard to maintain, and probably expensive. Well, fortunately, it's none of those, and I'll tell you why. So first things first, Postgres on Neon actually provisions in under a second. So here I have a demo, and the idea of this demo was to showcase how fast it is to provision Postgres on Neon. So you have a button, and this button just says deploy Postgres. You click on it, and in around a second, you have a connection string you can use. So here, this actually is a connection string that is usable, and there's even a SQL editor where you can run queries, and it works. So this is kind of why it's actually possible for you to do this. You can provision a database for every user, and it actually, the time it takes for the database to be ready won't affect the user experience. And in my app, I do it whenever a user signs up. So you could try it for yourself and see how long it takes for you to just sign up and log in like with Google. That's what I'm using. And it works. So this is kind of like, it must be hard to implement. The way it works is just, it's literally like one API call. Now let's talk about, it must be hard to maintain. Well, Postgres on Neon is fully managed. So once you provision a database, you can literally just set a minimum and a maximum size for the database's compute, and it will automatically scale up or down based on the application's workload. So if there are no incoming queries, the database can actually shut down to save on compute resources. And if there's a sudden spike in usage, what will happen is the database, like resources, will be dynamically allocated to meet the workload. So yeah, that's why it's not actually hard to maintain, but also why it's cost effective. Now, the last thing you might be wondering is, well, how would you manage schema changes across all these databases? Like if I have 1,000 users or 10,000 users, there will be 10,000 Postgres databases for each user. How would I evolve the schema for across all these databases? Well, because this is used in a way where it's just for a single feature, typically you wouldn't actually need to evolve the database schema. But if you want to, this demo actually contains a recipe that you can follow. So every time a user actually signs up, we actually use Drizzle, which is an ORM, to do the schema changes. And this is useful because now what we can do is actually automate the process of applying schema changes across all databases. So here you can see I have a folder called VectorDB, and there's a migrations folder inside it. And this is essentially the SQL. So we actually are defining the schema using TypeScript. So here you can see I just have a single embeddings table, and then we use Drizzle to generate the SQL. And if we want to apply those schema changes across all the databases, well, there's a simple script in the repo that you can use. And what it does is, well, we first get all the vector databases. So you can see we're doing select from all the vector databases. And then for each database, what we're doing is we're first getting the connection string using the Neon API, and we're connecting to the database. And once that's done, so we actually get the connection string. If there's no connection string, we throw an error. Then we establish a connection, and then we use Drizzle to migrate the database. So that's how you do it. Now, of course, this would be automatic if the changes you're introducing are backward compatible or non-breaking, which means you're not, like, let's say, renaming a column or dropping a table. So that's pretty much the trade-off, is whenever you want to evolve the schema across all those databases, you're going to have to be cautious about how you're doing it. And if you want to introduce a breaking change, it is possible. It will just be a lot more work, where maybe you do like the expand and contract pattern. So you introduce a column, you backfill the data, then you drop the column, and then that's how you do it with zero downtime. But of course, it's a lot more work. So yeah, that's it. This is the proposal. Let us know what you think. If you have any questions, feel free to reach out. We'd love to hear from you. And yeah, with that, thank you so much for watching, and I'll see you in the next one.